lesson, we'll be talking about factoring polynomial functions. So I'll be talking about simple and easy methods to factor polynomials. I like to classify them into 4 different types. So let us start with the first basic type. The first type, and I will start with an example for type 1. I like to call this as type 1. If we have to factor a polynomial function like this, which is a binomial. So in order to factor any polynomial, the very first thing that we should always look for is the greatest common factor. So I always like to start with finding the greatest common factor. So for any type of a polynomial, whether it's a binomial or it is a trinomial or even higher order polynomials, every time you start factoring, the first thing you always have to look for is the greatest common factor. So let us look at this binomial right here. So if you compare both of these terms here, we can easily see that the greatest common factor, a number that divides both of these terms, is 3. So we write that 3 outside, and then we draw 2 parentheses. Now in the parentheses we have to fill in 2 quantities so that when you distribute that 3 back, you should get back to the original polynomial function. So 3 times x squared is going to give us 3x squared back, and what would we multiply to 3 so that we get negative 6 back? The obvious choice is 3 times negative 2. So these 2 are the factors of this polynomial function. We should again go back to the basics and understand what does factoring actually mean. It simply means that given a polynomial or a number, you want to break it down into product of 2 or more. If you can break it down into product of more than 2, you should go ahead and do it. But in this case, if you look here, you can only break it into product of 2. This, we may be able to factor it, but we don't really have to factor this, because you cannot really, this is not a perfect square. If this was a perfect square, then we would have used a different method to do it. So for something like this, we can just stop right here and say this is the factoring for this binomial. Moving on to the second type. So I like to call this as type 1. Moving on to type 2. So I like to illustrate type 2 with an example. So let's say we have x squared plus 5x plus 6. You can see the difference between the example 2 and example 1. The very obvious difference is that this has 3 terms, and this is called a trinomial because this has 3 terms. This was a binomial right here. So now we want to factor this trinomial. And there is a standard method to factor the trinomials. Please remember, I would still start with looking for the greatest common factor, because that is always the first step to start with. But if you look at all these 3 terms right here, you cannot find a greatest common factor except for 1. Well, 1 is not going to help us to write the factors. We want to write the factors, so we have to use a different method. So I like to call this type 2. There are more than one ways to actually write the factors of this, but I would like to share the easiest possible way. The easiest method is you start drawing 2 parentheses, assuming, of course we are assuming that it has 2 factors. So that is our assumption. So we start by drawing 2 different parentheses, and then we fill in the first parentheses with an x and the second parentheses with an x as well, because x times x gives us x squared back. So this makes sense here to fill these 2 with x and x. Then to fill in the other part of the parentheses, we work with this constant number, in this case which is 6. So this method works for any type of trinomial where the leading coefficient, if there is 1, an invisible 1 in front of x squared. When there is a different number in front of x squared, that I like to call that as type 4, and we'll talk about that later. But this is the simpler type when the leading coefficient is an invisible 1, which it's not written here, but there is that invisible 1 right here. So what do we do in that case? We start by drawing the parentheses, filling in those x's here, and then we work with this constant 6. We try to come up with 2 factors of this number 6, the constant, not any two factors. We want two factors of this number 6 that add up to the middle term, that add up to this 5. So the obvious choice here would be 2 and 3. Why? Because 2 times 3 is 6 and 2 plus 3 at the same time is 5. Although 6 can also be factored as 1 times 6 or negative 1 times negative 6, but those factors are not going to add up to positive 5. So that's the reason why we want to use 2 and 3. So once we identify the correct factors that add up to the middle term, and that is always going to be the case for this type where the leading coefficient is 1. So we just fill in these two blanks with these two factors right here. So it's x plus 2 and x plus 3. So this is the factoring. These are the factors for this trinomial. We can always verify whether these are the right factors. To do that, we have to actually go backwards and we have to do the distribution. So if you want to convince yourselves that this actually are the factors, these are the correct factors, we can just distribute them and convince ourselves that these are the factors. For this example, let us actually go ahead and do that. X times x, x squared. I always like to draw these arrows. It helps me and it helps my students to do the right distribution. So x times x is x squared, then I do x times 3, which is positive 3x. That takes care of the x. Now let's move on to 2. So 2 times x again is 2x. And I have finally 2 times 3, which is positive 6, combining like terms, these two middle terms. So I have x squared plus 5x plus 6, which is the exact same thing that we started with. So that convinces us that these are the correct factors. Okay, so these are the first two types. I like to call this type 2 as a trinomial method. When the leading coefficient is 1. So I would also like to discuss the other two methods when the leading coefficient is different than 1 and also when we have more than 3 terms.